Emotions are an integrated response of our mind and body. They involve physiological arousal, expressive behaviors, and conscious experience. Emotions provide the energy and motivation that lets us meet our goals and needs and improve our performance despite sometimes getting in our way. But where do emotions come from? According to the James Lange theory of emotion, our feelings follow our bodily reactions to external situations. That, for example, you feel sad because you're crying or you're scared because you're shaking like a leaf. In contrast, the Cannon-Bard theory claims that our physiological responses to emotions are quite general, and that it's not easy to distinguish emotions from these responses alone. A racing heart, fluttering stomach, and sweaty hands could be attributed to passion, fear, excitement, or anger. A racing heart doesn't cause fear, nor does the feeling of fear result in a racing heart. Both things must happen together automatically. This theory gained preliminary support from studies in which participants received injections of epinephrine, which triggered nervousness, palpitations, flushing, tremors, and sweaty palms. These biological effects are similar to those associated with fear and rage, and so according to the James Lange theory, people detecting these effects in their bodies should experience these emotions. But that was not the case. Some of the participants who received injections simply reported the physical symptoms. Others said they felt as if they were angry or afraid, a kind of cold emotion, not the real thing. These reactions induced by the epinephrine were not sufficient to produce emotional experience. Though theories about emotions debate these and other details, the classic and time-honored view tying most theories together is that emotions are built in from birth, that unique neuronal pathways in our brains generate them, and they are universally felt and recognized across cultures. For each emotion, joy, surprise, sadness, anger, disgust, contempt, shame, fear, guilt, a unique set of physiological responses are triggered in our bodies and broadcast on our faces through smiles, frowns, sneers, and other expressions. According to this classical view, our emotions are artifacts of evolution, advantageous for survival, and fixed on our biological nature. In the 1960s, psychologists began to conduct cross-cultural experiments to demonstrate this universal, built-in nature of emotional expression. In a famous set of studies, American actors were photographed showing expressions that conveyed emotions like happiness, sadness, anger, and fear. These photographs were shown to members of various literate cultures, for example from Sweden, Japan, and Kenya, and to members of an isolated non-literate tribe in New Guinea. All participants who saw the photos were asked to pick the emotion label that matched each photograph. Each person was given a photograph and a set of emotion words. They then chose the word that best matches the face. Or, using a slightly different setup, a study participant is given 2 posed photos and a brief story, and then picks which face best matches the story. In other cases, the procedures were reversed. For example, the New Guinea tribesmen were photographed portraying the facial expressions that they considered appropriate to the various situations, like happiness at the return of a friend, grief at the death of a child, and anger at the start of a fight. American college students then looked at the photographs and judged which situation the tribesmen in each photo had been asked to convey. All of the participants were generally able to supply the appropriate emotion label for the photographs or match the appropriate expression with an emotional story. From this evidence, scientists concluded that emotion recognition is universal. No matter where you're born or grow up, you should be able to recognize facial expressions like those in the photos. However, there was a considerable variability across cultures in the actual recognition rates. 95% of US participants associated a smile with happiness, compared to only 69% of participants from Sumatra. 86% of US participants associated wrinkling of the nose with disgust, but only 60% of Japanese participants did. Previously, this variation was believed to reflect cultural differences in display rules, that is, rules about what emotions are appropriate to show in a given situation. A widely cited example comes from research in which American and Japanese participants were presented with disturbing surgical films. Participants first watched the films alone in a room, with their facial expressions recorded by a hidden camera. The facial reactions of Americans and Japanese were virtually identical, But when the participants then watched one of the films again while being interviewed by an experimenter, Japanese participants showed more positive emotions than the Americans showed, suggesting the presence of differences in cultural display rules of emotion. More recently, the wide variability seen in the hundreds of studies using the basic emotion method has been re-examined. The photos feature actors who were carefully coached and were supposed to be the easiest, clearest examples of facial expressions for each emotion. Study participants were also given a short list of emotion words to choose from. When researchers removed the list of emotion words, allowing study participants to freely label the same posed photographs, the success rate was no higher than 58%. When a more neutral question was asked without referring to emotion at all, such as, what word best describes what's going on inside this person, the performance was even lower. Cross-cultural research with the Himba tribes people of Namibia have confirmed this wide variability in identifying emotional expressions by removing all words from the experimental procedure. Himba study participants were simply asked to sort photos of facial expressions. They placed all the smiling faces into a single pile and most of the wide-eyed faces into a second pile, but then made many different piles with mixtures of the remaining faces. If emotion perception is universal, then the Himba subject should have sorted the photographs into 6 piles. When Himba participants were asked to freely label their piles, smiling faces were not happy but laughing, and wide-eyed faces were not fearful but looking. In recent research from the US, photos were used from the book In Character Actors Acting, in which actors portray emotions by posing their faces to match written situations. Study participants were divided into 3 groups. The first group read only the scenarios. For example, he just witnessed a shooting on his quiet tree-shaded block in Brooklyn. A second group saw only the facial configurations, such as Martin Landau's pose for the shooting scene. A third group saw the scenarios and the faces. Subjects were given a short list of emotion words to categorize whatever emotion they saw. 66% of participants who read the scenario rated the scenario as a fearful situation. But for those who saw Landau's face alone, without context, only 38% of them rated it as fear, and 56% rated it as surprise. Because this basic method of measuring emotions relies completely on human judgment, more objective techniques have also been used. For example, facial electromyography, or FEMG, places electrodes on the surface of the skin to detect the electrical signals that make facial muscles move. In a typical study, participants wear electrodes over their face as they view images or imagine situations to evoke a variety of emotions. Scientists record the electrical changes in muscle activity and calculate the degree of movement in each muscle during each emotion. Experiments using FEMG also presented a serious challenge to the universal view of emotion. In study after study, the muscle movements do not form predictable patterns for each emotion. Even more damning to the classical view of emotion, people worldwide can match emotion words to pose stereotypical expressions of actors, but those expressions can't be consistently detected by objective measures of facial muscle movements when people are actually feeling emotion. Scientists have also employed an alternative technique called the facial action coding system, in which trained observers classify a person's individual facial movements as they occur. In one study, researchers videotaped babies from various cultures, employing a growling gorilla toy to startle them, to induce fear, or restraining their arm to induce anger. They found, using facial action coding, that the range of babies' facial movements in the 2 situations was indistinguishable. And it's not that newborn babies and young infants don't move their faces in meaningful ways. They might be interested or puzzled or feel distress in response to an offending taste, but newborns don't show differentiated adult-like expressions like the photographs from the basic emotion method. This suggests that specific emotional expressions are neither universal nor built-in. Despite evidence refuting the classical view of emotion, tech companies like Microsoft, IBM, and Amazon all sell what they call emotion recognition technology, which reads how people feel based on facial analysis. The technology relies on an artificial intelligence technique known as machine learning, algorithms that process data to learn how to make decisions to accomplish even more accurate emotion recognition. Clients are interested in putting this kind of technology to use in anything from automated surveillance systems that look for angry threats in public spaces to job interview software that promises to weed out bored candidates. But while machine learning excels at finding new connections, these connections are not always meaningful and can lead to spurious results. like scanning babysitters' social media posts to detect their attitude, or analyzing corporate transcripts of earnings calls to predict stock prices. In a recent review conducted by 5 distinguished scientists in the field of emotion, 1,000 studies on the digital recognition of facial expression were scrutinized, and the conclusion was unanimous. Emotions are expressed in a huge variety of ways, and with current technology, emotions cannot be reliably inferred from facial movements. The data showed that more than 70% of the time, people do not scowl when they're angry. And on top of that, they scowl often when they're not angry. So you would be making your decisions based on an algorithm that is accurate only 30% of the time. According to a report by the AI Now Institute, an interdisciplinary research center studying the societal implications of artificial intelligence, emotion recognition technology is dangerous to use in decisions that impact people's lives and access to opportunities. Still, the highly conclusive findings are rarely acknowledged by companies selling emotion recognition tools. For example, in marketing for Microsoft's algorithms, the company says advances in AI allow its software to recognize 8 core emotional states based on universal facial expression that reflect those feelings. Other researchers are looking into combining facial movement with metrics like speech, gait analysis, and eye tracking, though there's no evidence currently that these will result in more reliable predictions of emotion. While it's possible to do some pretty remarkable things with technology, like recognizing individuals' faces, the ability to infer human emotions is not yet possible. The expression of emotions is varied, complex, and situational, and your brain relies on many different factors at once. Body posture, voice, the overall situation, your lifetime of experience to figure out which movements are meaningful and what they mean. It's a tall order for machine learning programs when they're missing out on most of this key information. But I can hear you yelling.
What about brain regions that have been reliably linked to specific emotions?
Maybe the answer is not to read faces, but to read brains. The amygdala, for example, was linked to fear in the 1930s when 2 scientists removed the temporal lobes of rhesus monkeys. After the surgery, these monkeys approached objects and animals that would normally frighten them without hesitation. The most intensively studied human case is a woman known as SM, afflicted with a genetic disease that destroyed her amygdala. Born in 1965, SM was, and still is, mentally healthy and of normal intelligence, but when exposing her to fearful situations, she reported no strong feelings of fear. When SM was shown wide-eyed facial configurations from photos, she had difficulty identifying them as fearful. But then, a funny thing happened. Scientists found that SM could see fear in body postures and hear fear in voices. They even found a way to make SM feel terror by asking her to breathe air that was loaded with extra carbon dioxide, causing no actual harm. So SM could clearly feel and perceive fear under certain circumstances, even without her amygdala. The amygdala not being involved in all fear responses has been further confirmed based on a recent review of over 100 published fMRI studies across almost 20 years of research. The amygdala actually shows increased activity in only a quarter of fear experience studies and about 40% of fear perception studies. In fact, no individual section of any brain region appeared to be activated in all the scans of fear. This was also true when looking at other emotions. Emotions do arise from firing neurons in the brain, but no set of neurons are exclusively dedicated to any specific emotion or even emotions in general. In her 2017 book, How Emotions Are Made, Lisa Feldman Barrett proposes the theory of constructed emotion to better fit the available evidence. According to this theory, what we call emotions are better thought of as emotion categories, because each is a collection of diverse instances. Rather than emotions being built in and triggered, they are created. Instead of being universal, they vary from culture to culture. Emotions emerge as a combination of the physical properties of your body, a flexible brain that wires itself to whatever environment it develops in, and your culture and upbringing which provide that environment. From your brain's perspective, check this out. Your body is just another source of sensory input. Sensations from your heart and lungs, your metabolism, your changing temperature have no objective psychological meaning. Once your concepts enter the picture, however, those sensations take on meaning. Take, for example, the famous bridge study. Researchers had a female college student stand on a scary, swaying suspension bridge. And every time a young man walked across by himself, she would stop him and say, "Excuse me."
I'm doing an experiment for my psychology class on the effects of exposure to scenic attractions on creative expression. Would you mind filling out this questionnaire for me, please? Here's a pen.
They filled out the questionnaire while the bridge rocked and swayed, their stomachs dropping, their hearts pounding.
And then I have a picture for you to look at. And I'd like for you to write a brief dramatic story based on this photograph.
So the man would write the story, and when he was done, she'd say,
"Thank you, I appreciate your time. And I don't have a whole lot of time now, but I'd love to explain the experiment in more detail when I do have more time. So I'm going to give you my number, and then you can feel free to call me. It's at my hotel."
Okay.
She would write down her name and phone number and hand it to him.
My name's Linda, so
Okay.
I hope you call me.
Okay, Linda.
She stopped 20 men on the scary bridge, and then she stopped another 20 men on a separate bridge that was big, heavy, and safe, that wouldn't evoke any sort of physiological arousal.
I am doing a project for my psychology class on the effects of exposure.
Among the men who met her on the scary bridge, many more phoned her that night than those who met her on the safe bridge. And when the stories were analyzed, there was far more romantic content written on the scary bridge than on the safe bridge. For example, from the scary bridge, one story read, "She's embarrassed because her boyfriend wants to marry her," compared to the safe bridge, which includes stories like, "I think this woman is a little embarrassed about something that's really not that important at all." These findings have been interpreted as a case of fear being constructed as attraction. The neural process of construction creates feelings of attraction from a fluttering stomach and a racing pulse. According to the theory of constructed emotion, an emotion is your brain's creation of what your bodily sensations mean in relation to what's going on around you. In every waking moment, your brain uses past experience organized as concepts to guide your actions and give your sensations meaning. If you feel an ache in your stomach while sitting at the dinner table, you might experience it as hunger. If you're a judge in a courtroom, you might experience the ache as a gut feeling that the defendant cannot be trusted. In a given moment, in a given context, your brain uses concepts to give meaning to internal sensations as well as to external sensations from the world, all simultaneously. Construction of emotions, according to this theory, is not a unique mental process, but the same type of process involved in thinking, remembering, perceiving, learning, and choosing. Your brain is not a passive receiver of sensory input, but an active constructor of it. This means that on different occasions, in different contexts, in different studies, within the same individual or across different individuals, the same emotion category involves different responses. Variation, not uniformity, is the norm. Yet another way of thinking about emotion that seems to fit the current evidence is something known as the Circumplex model of affect. The idea that any of the emotions you might feel are expressed on a spectrum and as a combination of valence, roughly speaking positive or negative, and arousal, excited or not excited. So potentially every emotion can fall in degrees on this two-dimensional scale where each emotion can be understood as a linear combination of these two dimensions, valence and arousal. Joy, for example, would be conceptualized as strong positive valence and moderate arousal. Fear is conceptualized as the combination of negative valence and high arousal. Other affective states, emotions, also come from the same two neurophysiological systems, but differ in the extent of activation. Proponents of the Circumplex model believe that similar to the spectrum of color, emotions lack the discrete borders that would clearly differentiate one emotion from the other. In fact, detailed study of the intercorrelations among emotional experiences has repeatedly yielded two-dimensional models based on valence and arousal. These are robust and highly replicated findings, and they indicate that participants who report feeling sad are also likely to report feeling angry, down, guilty, and so forth, whereas subjects who report feeling good are also likely to report experiencing other positively valenced emotions. So we're constantly constructing emotions without even realizing it, possibly based on emotion concepts as proposed by the theory of constructed emotion, or through our dimensional interpretation of valence, positivity or negativity, as well as level of arousal. But what do we know about the more conscious process of controlling our emotions? Emotion regulation means influencing which emotions we have, when we have them, and how we experience or express them. It usually involves efforts to decrease the experiences or behaviors associated with anxiety, sadness, and anger. Two forms of emotion regulation that have received the most research attention include cognitive reappraisal and suppression. Cognitive reappraisal occurs when someone tries to decrease an emotional response by changing the meaning of a situation. For example, instead of thinking of a job interview as a matter of life or death, a person might think about the interview as a chance to learn more about the company to see whether it would be fun to work there. Suppression occurs when someone tries to decrease the emotion they show on their face or in their behavior. For example, instead of bursting into tears when receiving disappointing news, a person might put on a brave face. While both strategies can decrease emotional behavior, reappraisal seems to be a more effective way to regulate emotions. In part, this is because someone who suppresses an emotional reaction might block the display of emotion but does not make the feelings go away. In fact, physiologically, suppression leads to even greater sympathetic nervous system activation. And there's also a cognitive cost to suppression. When participants in an experiment were asked to suppress their emotions, they performed as badly on later memory tasks as people who had been encouraged not to pay any attention at all. In contrast, reappraisal can make a person feel better and it doesn't seem to have the cognitive or physiological costs. In one study, researchers showed participants neutral or negative emotion eliciting slides during an fMRI study. Participants were asked to either view the negative emotion eliciting slides or to reappraise them by altering their meaning. For example, a participant might see a picture of a woman crying in front of a church. Instead of thinking of a funeral scene, the participant might try to think of it as a wedding scene that brought the woman to tears of joy. Participants reported feeling less negative emotion when reappraising than they did when just watching the negative slides. For as long as scholars and scientists have been writing about the human mind, they've been speculating on the nature of emotion. The theories that attempt to explain them have only fostered more intense research. With the advent of new technologies in neuroscience and artificial intelligence, the next 100 years of emotion research promises to be even more illuminating.